All right, I'm back. I'm trying to do this a little bit more of an unconventional way, and we're trying to simplify radicals or extract the square roots. And so I'm picking some numbers that may not necessarily be the highest number. So when you're thinking about reducing things, you want to pick the highest number possible because it's just less steps. But I'm going to show you that most people don't necessarily always pick the highest number. And in which case, if you do that, that's okay. You can still end up with the right answer. It just means a little bit more work. So again, if you'd like to find more questions like these, please look at my playlists, my roots and exponents playlists in my YouTube, my TikTok, and my Instagram at YouWantAlgebra. So what I'm going to do is think about two numbers that multiply to get me 512. And so you can, again, you're trying to pick the highest number possible, but that's a perfect square. But if it doesn't happen, it doesn't happen. So I'm going to show you a bigger number, but not the best number. So 16 is a perfect square. So I'm going to use 16 and 32 because those do multiply to get me 512. But I have some work still to do with the number 32. So I have perfect square, right? The perfect square of 16 is going to be 4. So we have that. You have numbers. Numbers times numbers can work. They can multiply. Roots times roots can multiply. You just can't multiply roots and just numbers. So now what I'm going to do is look at 32, and I'm going to think of a possible set of numbers that goes into 32 that works. And the first one that comes to my mind is 4 times 8. So I'm going to put that, and I've got that. Now the square root of 4, that's another perfect square, which is 2. So right now I have these two numbers, and so I do have, I'm just going to rewrite this so you can kind of keep track of this. So you've got 4 times 2 times the square root of 8. Now that's still not simplified all the way because 8 has two numbers that can go into it besides itself. Square root of 4, square root of 2. Square root of 4 is another perfect square. Again, as you can see, there's another 2. So now you have 4 times 2 times 2, and then you have that square root of 2. So I'm just going to kind of show you this right here. And so now you have 4 times 2 times the other 2 times the square root of 2. Multiply our numbers. 4 times 2 times 2, and that's going to give you 16. And then we're going to have 16 root 2. And that will be my finalized answer after I simplify all things. Now we're going to go ahead and we'll do that one down here. Again, I'm not showing you the fastest way. I'm trying to just show you a different way so that you can see that you can do this a variety of ways. All right, so let's take this. Now I could simply multiply these two numbers together, the 12 and the root 12 and the root 6, and I can most definitely do that if I'd like, and I just end up with a bigger root number. I'm going to show you that we're going to do it this way. We're going to do 4 and 3. Because those multiply to get me 12. I've got a perfect right here, so that's 2. Now we cannot forget about that 3, so I'm going to bring it down. So I've got 3 times this 2 times the root 3. Now I'm going to do this and break it down. Two numbers that go into 6 besides itself, 2 and 3. So now I'm going to see, I see a pair of, 3 roots. Okay, so I'm going to show you that one in a second. So I'm going to rewrite this actually, root 3, root 2. So I've got all that. Now what you're going to notice is you have a pair of roots right here that are exactly identical. When they're identical, you wipe away the root symbol, and it's just the number that's there. So now we're left with 3 times 2. Now this pair is going to be 3, and then root 2, which is a prime. I can't do anything further with it. And then I just multiply the 3 times 2 times 3, which you're going to get 18 root 2. And that is my finalized answer. If you'd like more questions like this, like I said, find them on my YouTube, Instagram, and my TikTok at YouWantAlgebra under the Roots and Exponents section.